you will always have in a pre-calculus class, meaning you don't have imaginary numbers for your coefficients. What does that mean about the number, potentially, the number of x-intercepts? How many x-intercepts am I guaranteed to be able to have at maximum, like my maximum number of x-intercepts, or also called roots, or real zeros? How many of them am I guaranteed? Well, it turns out the maximum number that you could have is the actual size of your degree. So if I have a degree 2 polynomial, like parabola, okay, degree 2 polynomial, I could have up to, maximum number, 2 x-intercepts. That kind of makes sense. When you remember the quadratic equation, you could have that plus or minus, you could get up to 2 answers there, right? But if I had a degree 3 polynomial, I could have up to 3 x-intercepts. And the one that we just did, this guy, degree 4 polynomial, I could have up to 4 x-intercepts. So by looking just at the degree, I'll know the maximum number of x-intercepts. The way we refer to x-intercepts in math speak is real zeros. If you remember back in your college algebra or intermediate or high school algebra days, when you were solving a quadratic degree 2 equation, sometimes using your quadratic formula or taking the square roots, you ended up with I, right? Imaginary results. Whenever you got those imaginary results, hopefully your teachers told you, this means that there are no x-intercepts. Okay? Hopefully you remember hearing something like that. That's because x-intercepts are what we mean by real zeros, real answers for those solutions. When we get imaginary results, while they are important in giving us the shape, they help play a role in the shape of the polynomial where we have terms and such, they're not going to be x-intercepts. They're not going to provide x-intercepts. So the only time we'll get x-intercepts are when we get real zeros. And we'll see later on in chapter 2, you'll be finding some zeros of a function, polynomial function, and some of them will be real, meaning x-intercepts, and some of them will be imaginary, meaning not x-intercepts. They're just helping create the shape of the graph. Okay. So how many x-intercepts could I have? How many real zeros could I have? Up to the degree. Okay. And you can think about a parabola, how that works. You can have none, 0, 1 for a degree 2 polynomial.